Hai, Assalamualaikum. So, minggu ni kita akan sambung bincang example untuk Principle of Conservation of Energy. Okay, let's take a look at example 12 here. A roller coaster car shown in the figure is pulled up to point 1, where it is released from rest. Assuming no friction, calculate the speed at points 2, 3, and 4. Okay, so we have a roller coaster here, okay? Although the image is not clear, but this is a roller coaster car at 4 points, 4 different points. Okay, so initially the car is here at point 1, where it is released from rest. Okay, it is released from rest, meaning that the velocity at point 1 is equal to 0. And then as it is released, it will go through the point 2, 3, and 4, where it will have different energy involved here. Okay, so we want to find what is the speed here, point 2, point 3, and point 4. So 3 speeds we need to calculate. Okay, so in order to solve this kind of problem, which we involve the conservation of energy, okay, remember the first step is to define the system. How do we define the system? Okay, we need to identify what is the object involved here. Do we have more than 2 objects or we only have 1 object? Okay, so in this case, obviously we only have 1 object, which is the roller coaster car. We don't have any other car, we don't have any other blocks or spring, okay? So only 1 object. So we can only focus on this roller coaster car only. Okay, so the next thing we need to do, the next step is to choose the location where we can define as h equal to 0. Okay, so remember we need to always define that position. We either want it here or here or here. The easiest way is, okay, we define it here. Usually we will choose the location close to the ground or on the ground to make it h is equal to 0. Okay, so here h is equal to 0. And then since we are already given all of this value of h1, h3, and h2, this one here, so it is easy, just choose this location as h is equal to 0. Okay. The next step is we need to identify which is the initial, which is the final. So this one is based on what we want. Okay, we'll get to it later on. And then after that, we just solve for the unknown actually. Okay, there's not much steps. Okay, so now let's see, the first thing we need to do is we need to find the speed at point A. So V2. Let's just label it as V2. Okay, and then this one is V1 here. V1 is equal to 0. So we have V2, V3, and V4. Okay, so now in order to find V2, we need to choose the initial and final position. So because we have the information at V1, so we can choose this as V1, this one as V2. Okay, so now the initial is point 1, and then the final will be point 2. So this one you don't really need to write it down, it's just as a guide for you. Okay, so we we put it here, point initial, and here is the final. Okay, now let's write down the conservation of energy, the principle of conservation of energy, where we have the sum of energy initial equal to the sum of energy final. Okay, so dekat initial, what energy is involved? Okay, so since the velocity is equal to 0, so we don't have kinetic energy. So here, kinetic energy equal to 0. And since it is, okay, we have a certain height here. So we have the potential energy. So potential energy, we do have it. Okay, but we don't know what is the value yet. So just masukkan. Dekat initial kita hanya ada satu potential energy. Potential energy initial is equal to the at final. Okay, here, when it is released, obviously it will be moving all the way up until point 4. So at this position, and this position, the car is moving, meaning that there is velocity. If there is no velocity, why did the question ask for the value, kan? So obviously there is a velocity, so meaning that there is a kinetic energy. So here we do have kinetic energy, but since it is on the position where we have h is equal to 0, there is no potential energy. So potential energy, no potential energy. So we're left with potential energy initial is equal to kinetic energy final. So just masukkan sahaja the formula mv2 squared. This is what we want. And here is the h1, this one. So h1. Okay, and then, okay, we are not given the mass, so we can just cancel out these two. And then masukkan h1 is equal to 32 meter. So make sure the value of the height that we are given is in SI unit. And then just masukkan half V2 square. So you will get V2 is equal to, it will be equal to 25.06 meter per second. Okay, so that's one is for V2. Now we want to find V3 here. Okay, V3. Now soalan B, V3. Okay, so sama juga, we need to choose which one is the initial, which one is the final. Okay, so yang senang, you can either use this one or this one as the initial point. Okay, as long as it is in front lah, sebelum position 3, dia mesti sebelum position 3. Okay, sebenarnya dua-dua pun senang because dekat position 1, kita hanya ada satu energy yang terlibat, which is potential energy. Dekat position 2 juga, kita hanya ada satu energy yang terlibat, which is kinetic energy. So, usually we will choose the position where we have only one energy involved. So, since kedua-duanya ada satu energy saja yang terlibat, so it doesn't matter, you can choose either one. So, now what I want is I want to choose this one as initial. So, this one is no longer the final one. Dekat sini sudah kita punya position for the final one. Okay. So, obviously here we have a certain height. And as I said, since it is moving, still moving along the way, we have both kinetic energy. So, we have both kinetic energy and potential energy. So, that one will be the final. So, just masukkan. Okay, biasakan tulis this one. Okay, this is the concept. You will get the mark for the concept here. Kamu akan dapat markah konsep dekat sini. So, biasakan tulis this one, the formula. And then masukkan. Di mana initial kita ada potential energy sama dengan kinetic energy final tambah potential energy final. And then just masukkan saja mgh1 half mv3 square plus mgh. What is the value for h here? This is h3. Okay, so mass, we can cancel them and then masukkan yang lain. And then h3 is 26 meter. So kamu boleh selesaikan value v3 which is equal to 10.85 meter per second. Okay, so last one is the speed at point 4. So this one sama, we repeat the same steps, which is to identify which one is the initial, which one is the final. So senang kita stick with this one initial, this one akan jadi final dekat sini. So here final, where we have a certain height and we have the velocity. So akan ada kedua-duanya kinetic energy, we have potential energy pun kita ada. So now V4, so the sum of initial energy is equal to the sum of final energy, di mana initial kita hanya ada satu potential energy dan final ada kedua-duanya. Okay, so again initial here H1 mgh1, so this one mgh h2 here, this one, okay, plus half mv4 square. So this one just cancel them and then masukkan value. H1 tadi 32. H2, what is the value for H2? It's 14. Plus half V4 square. So you will get V4 is equal to 18.79 meter per second. So don't forget the square here. Okay, so it's very easy as long as you identify what are the energy involved at each point, and then you determine, you select which location you want to be the initial, which one you want to be the final. Okay.